on this computer. Excellent. And then we've got this to refer back to. Where were we? Full screen, please. Navigating around your viewports, basically, I just encourage you to have a go. So what does a scroll wheel do? Scroll wheel zooms you in and out of the 4 viewports. And if you put your mouse on a viewport and scroll, that will let you see things closer or further away. The top, front, and right viewports are orthogonal. So when you right click and drag, they move like you're looking at a painting, left, right, up, down. So right click and drag is how you move your viewport. And right click and drag in perspective will do this thing called tumbling, which you're probably familiar with if you've used 3D modeling software before, but you're basically rotating around a fixed center. So if you want to try that, one thing that gets really annoying, and this is like a really good tip to start with, is that let's go, so you can see the sort of stuff right at the end of this project. Let's click on something over there, like this curve. And I want to say, okay, I want to go and have a look at that, please. This thing that's quite a long way away from the center. And what you'll do is you'll zoom in with your mouse, and then suddenly your zooming will start being really slow and sluggish and unresponsive. And then when you start doing this, it's like, oh, it doesn't quite go where I wanted it to go, or it's rotating around a thing that isn't quite in the center. And then what you'll find yourself having to do is go, okay, what I want to do is move my camera like left and right rather than tumbling around. And so you hold down Shift and right click and drag. And then what you'll see is rather than tumbling, you're moving the camera up, down, left, right. So the thing to get used to is one hand with your little finger on the Shift key and your mouse hand with your finger on the right mouse button is how you move around. And either you hold down Shift to move the dolly the camera, or you just click and drag to rotate the camera. Then a really cool button is on your standard tab at the top. There's a little yellow magnifying glass. Can you see that? It's a really useful button. If you get lost, this is the button to click. Yellow magnifying glass. So select a thing. Like at the moment, I've clicked on this square, this rectangle down there, and click on that thing there, and you'll see your perspective just sort of goes, whoop, moves around. And now, when you tumble, you're tumbling to the exact center of that object. That makes sense? So when you get lost, that's how you find your way again. And we'll zoom out and we'll move across and we'll click on this square and we'll click that little yellow magnifying glass. And now, whoop, now we're back and I can tumble around this part of the model. So just encourage you to kind of get used to that and be nice and fluid in moving around. Next thing is these viewports, you don't have to have all 4 of them open at once. So you double click on the name of the viewport and it makes it big. And you can double click on the name of the viewport again, makes it small. Big, small, big, small. Okay, so we've got viewports, we've got navigation and display. In the viewports, you also have display modes. So under perspective, there's a little tiny arrow right at the end of it. And you click that and it gives you this big menu with a whole load of stuff. The thing that we really care about are these options at the side: shaded, rendered, ghosted, X-ray, blah, 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 all sorts of things. Let's switch it to shaded and we'll go and have a look at our people. Let's zoom in on this guy here. He's called Guy. Can you get up close to the guy? Click on the guy. Maybe if you're finding it hard, click on the guy and press your yellow magnifying glass so you know he's right in the middle of your thing. Okay. And then we'll change to wireframe. See how the guy changes? We're looking at the wires that make up that mesh. And in this case, we're looking at the faces. And you can try rendered, give you a nice shady view. Looks quite nice. You can try ghosted, and ghosted is how I like to work personally. Ghosted means that we can see through, it's quite difficult to see, but you can see through things. Can you see, I can like see kind of through this mesh. It's like half transparent and half shaded. So we'll leave it on ghosted for now. Plus you can have different view modes for your top, your front, and your right. So we can set right to be rendered, front to be wireframe, and top to be wireframe, and perspective to be ghosted. They're all independent. Generally speaking, the orthogonal views are best kept wireframes. Right. 5 minutes. Now we know how to navigate Rhino. Everyone happy with that? Yep. Great. Selecting things. Oh, actually, no, before we go any further, why have I put some people right at the origin of this file? The scale reference. I have a little sort of, what's the word? Just a rule in my head that I never do anything in Rhino without putting a person next to it, because it's so easy without people to completely lose the sense of how big something is or how small something is. You spent hours and hours on something and then you realize that it's just like, it doesn't work, because when you put a person next to it, they're going to bump their head or, you know, whatever it is. So Guy is my favorite because he's like really low poly. He's very like only just like a couple of hundred meshes, 34 meshes. There we go. Gary, you can see he's got like loads more mesh. So he's useful for like rendering and stuff. But Guy is really useful for modeling. And you know what else? We model everything for like a 6 foot tall man. Well, shall we maybe include some people sitting down, or maybe some people who aren't 6 foot tall, maybe some people who aren't men in our models? You know, hashtag. What's that? How tall is Gertrude? Ah, should we find out? Okay, how do we find out how tall Gertrude might be? Distance. Oh, we're getting way into it now. Start typing the word distance, and we're going to measure from her heel up to the top of her head. She is 1,614 millimeters. So she's 5'6" She's a tall woman, but again, you kind of want the taller end in terms of making things feel nice and spacious. Yes, it is. Yeah. Okay. People are important, and you'll notice that I've copied my person across to each of these things.
There's a, how do you, obviously that home I've got set up, how I want it set up and now.
Yeah.
There's a way so that when you draw a line, it automatically comes up with the measurement.
I'm sure there is a way.
I'd have to YouTube it as well. I think it's like 3 settings or
yeah.
So much easier,
yeah. Also, you can draw lines with exact dimensions as well. We'll get to that in just a minute, actually. Okay, so selection, you've probably worked out you can click on a thing and it selects it, turns nice and yellow color, and hopefully it should give you a gumball, which is this thing with the arrows pointing out of it. And okay, if it doesn't, go down to the bottom of your screen and you see this thing: grid snap, ortho, planar, OSnap, smart track, gumball, record history, filter, blah, blah, blah. Just turn gumball on and then it should give you that. Okay. And you can also, exactly the same as CAD, if you use AutoCAD, drag from the left to the right, right to the left, and it'll select everything it touches, you know, like the Lion King, everything the light touches, Simba. And you can drag from the left to the right, and it'll select everything that's fully enclosed within your square. There's other ways you can select. You can select by layer. So people names is a layer. There's a sub layer underneath people. And if you don't see the layers, then you might need to find that little cake slice icon on the top right of your screen and turn that on. You might be on properties, or you might be on like help or something like that, or welcome to Rhino. Well, find your little cake slice, and you can right click on names and choose select objects, and it'll select all the objects on that layer for you, which is a good sneak preview as to why layers are really, really, really useful. We're going to be using layers a lot. Just move that out of the way. Okay. And then you can also type cell text. It'll select all the text in the file. Or you can type cell curve, which Rhino spells CRV, cell curve. And click enter, and it'll select all of the curves. You could select by color if you really wanted to, cell color. And it'll say select an object with a target color. So maybe I want to select an object with a target color is this orange thing. And then press enter, and it'll select all the orange things in the file. These are all really useful things. We'll get into them as we go, but use it how you want to use it. Now that's all fine, but let's actually start making some stuff, shall we? I've put a little challenge in this orange square. So let's set our viewport up to be focused on this orange square. And what I want you to do is to draw on the curves layer. The way we're going to do that is by double clicking on curves, it will turn bold. So now we're working on the curves layer. Everything that you do now will be on that layer. Draw on that layer a point, a polyline with 3 control points, a curve with 3 control points, a closed curve with 5 control points, and a circle with a radius of exactly 1 meter, and a rectangle on the ground plane that's 500 by 1200. Now, some of us probably who are used to Rhino can probably do this now standing on our heads. Some of us, you might be new to it. Shall I go through, or do you want to try and have a go and work it out yourself? What would you prefer?
Can you go through?
I'll go through. Okay. All right. So now we want to draw something. There are two main ways of doing it. You can use a button, and what the button does is it says, get my system ready to put down a thing, or get my system ready to do something. The point button is in the standard toolbar, top right of this little thing here. Can everyone see on the screen? Single point. So I click it, and then I look up here and I see this bold text, and it says location of point objects. And my cursor has changed to this like crosshair thing, and it's got a little point that's kind of dragging around. Everyone with me so far? Mm-hmm. All I now need to do is click, and it puts down a point. So think of it like this. You load your gun with ammunition, and then you fire your gun. So you load up your mouse with a point, and then you fire onto the 3D surface, onto the 3D landscape. So I put a point down, and if I select it, it will tell me that it's on the curves layer. It's got a little thing down the bottom to tell me which layer the thing is that I've just selected. That's on curves. If I select this guy, he says he's on people. Let's do a polyline with 3 control points. So what you'll find is if you hover over these, they all have names. So now we want to find the one that's called polyline. And it's just next to the point down and across to the left. We load up our gun with a polyline, and we put a polyline down with 3 control points, which means we click 1, 2, 3. And then how do you think we get out of that?
Right click, left.
If you press escape, what happens?
It doesn't do it.
Aha, okay. So those of you who are like Revit people,
Oh yeah, I just did that.
right.
Now,
If you're a Revit person, you need to unlearn escape. And you need to read what it says. It says press enter when done. Or space. Space and enter are the same thing.
right click works as well.
Right click works as well. Right click's really nice because right click also, well, so does enter and space. It redoes the last command. So rather than having to go, okay, I need to go and press the button again, you can just right click and do another one. And then right click and do another one if you want to practice. Okay, so there's a polyline with 3 control points. And then where do you think we might find the curve? Same place, control point curve. So we load up our gun with a control point curve tool and we put 3 control points in. And you see how it kind of dynamically works itself out. Press enter when done. There we go.
Screen's freaking out a little bit.
Oh, is it? Oh, it is, isn't it?
I found out how to bring up the distance if it's helpful.
Oh, yeah.
File properties, and then so yeah, modeling aids, cursor tooltips, and then click distance.
Modeling age, cursor tooltips, distance. Oh, there you go. It's nice, isn't it? Very nice. Okay, cool. Now, how do you think we're going to do a closed curve? We're going to load up our gun with a control point curve tool. We're going to put 5 points down, 3, 4, but the last one, as soon as you come near it, what you should find is that your cursor does this. Is anyone's cursor not doing that? As soon as you bring it close, it goes whoop, and then becomes closed. Anyone's cursor not doing that? If it isn't, it's because your snapping tool is switched off, your object snap is switched off, and your O snap is switched on, but end isn't highlighted, or point isn't highlighted. Cool. Okay, good. And a circle with a radius of exactly 1 meter. Here's the cool thing. The next thing down, circle. Now it says center of circle. We click our mouse once, and then it says this thing called radius. Now you can click and drag a radius, and down in the bottom left corner, you'll see these numbers. You know, 1927.035 millimeters. And that's trying to do the best it can to read from your mouse position what the radius of that circle is going to be. So if you said to yourself, okay, I really want it to be exactly 1 meter, you could really, really carefully move your mouse to try and, you know, exactly get 1,000 millimeters, but it's not going to work. You'll get 1,000 millimeters 0.001 or something, or 1,001 millimeters 0.429. And it's not accurate at all. However, what you can do is type into this top bit here, and you can say, radius. Well, it's asking me for a radius, so I'll type 1,000 and I'll click enter. And then if we go down here and type distance, and we'll go from this side of the circle to the other side of the circle, it's exactly 2,000 millimeters. So rather than just loading up your gun, your mouse gun with a thing and then using mouse clicks to put something down, you can use a combination of mouse clicks and numbers that you type into the command. Okay. And similarly, a rectangle on the ground plane that's 500 millimeters by 1,200 millimeters. So we find the rectangle tool first corner of the rectangle is asking for a mouse click. So we're going to put down a mouse click. Other corner or length, we're going to type 500. Width, 1200. Enter, we're done. Everyone got something that sort of roughly looks like that? Any questions? Okay. Some extra things. If you want to go on and have a look at polygons, how do you think we're going to do a polygon? Can you see a polygon command anywhere here? Yeah, where? Underneath the arc. Yes. You know what's better than searching for a tiny button is knowing what you want and just telling Rhino what it is. So why don't we just type polygon? And I just want to sort of like put out there that I now don't really use the buttons at all. If I know what I'm asking Rhino to do, I'll type it. And what Rhino's really, really, really good at is going, I've started typing poly, and it knows that the last thing that I did that had the word poly in it was a polyline. So it auto-completed it as polyline. It said, well, the last thing you did was a polyline, and you seem to have done quite a few polylines. So do you mean polyline? So all I really had to type was PO, maybe POL, and it was like, oh, you want a polyline. Now, instead, I was like, actually, no, this time I want a polygon. So I started typing a little bit more. I got to G of polygon, and it auto-completed it. And now I can say, okay, where's the center? And number of sides. And there's all these cool little, options in there that I suggest that you just have a play around with. The number of sides is going to be, at the moment, is 5. So that's not going to give us exactly what we want, but we click on that and it says, how many sides do you want? Type 7. And then let's make a 7-sided polygon. Job done. Happy with that? An equilateral triangle. What's an equilateral triangle when it's at home? A 3-sided polygon. Brilliant. So polygon, number of sides, 3. There it is. And if you want to make sure that your shape is orthogonally located on your ground plane, you can hold down Shift when you click the next point, and it will make sure that it snaps to an XYZ plane. And then isosceles triangle. How are we going to make an isosceles triangle? Does everyone know what an isosceles triangle is from like Key Stage 3 maths? How might we make an isosceles triangle? Speak up. Two sides longer than the other one, but those two sides are exactly the same length. Is there a command for it? There you go. Okay, great. So once you've put down a shape, when you click on it, you see these points appear. And that means that you can change the shape once you've drawn it. So if I do an equilateral triangle and then pick one of the points and move it out, then I get an isosceles triangle. So just highlighting there that the thing that you want might not be in the drawer, but I absolutely guarantee you with the tools that you have, you can make whatever it is that you want.
How did you make those sides?
Okay, so I put down a polygon and I told it that the number of sides I wanted was 3, and a polygon will always make a regular shape. So every side is the same. So then I held down Shift to align it with the XYZ plane. And then I clicked on it and I picked one of these points. I zoomed in and I picked that point was the construction point, and then I just dragged it out. And now I know that these two sides are the same length because I know that this is going exactly in the Y direction. I held down shift to draw it to make sure that it was exactly aligned properly. No, when you click on it, you see each corner has a point. And then once it shows you those points, I clicked on the one that I wanted to move. And then I dragged the red arrow on that point, not the red arrow on the whole shape, because that would move the whole thing. Okay. Now that, what I've just described to you there, that is how modeling with Rhino works, where you start with simple things and then you build up to more complex things. How's everyone doing? Are we awake? Have we had enough coffee this morning? Good. Crack on. Okay, good. How are we doing online? Thumbs up. Is this teaching grandmother to suck eggs? Going too fast, too slow, bit too slow? About right. Okay, good. Shout loud if you want something different. Okay. Yeah. We're definitely going to have, because this is like your brain's going to try and keep up. You're making notes. I would really I would commend making notes, because like we were talking about before, this is like playing a musical instrument. You maybe have a lesson, but you learn by practicing. So you need to practice this in the week and keep going. That's why I'm sending you this file, because this file, then you can save this file and you can come back to it and say, how did I do that? Yeah. Right, let's look at solids and gumballs, snaps, and seaplanes. Oh, we're getting cool now. Okay. All right. Here's a little question. When you, if you were looking in the perspective view, when you put down these shapes, where did they end up going? On the ground, on the floor, right? Doesn't matter like exactly what view you were looking at. As soon as you clicked, it's like you were looking at the floor, and that's where you clicked. And what that tells you is that Rhino is working with a construction plane that is the ground plane. And a construction plane is when you make something new, where should I put this thing and how should I orient it? And by default, that is the ground with the Z direction up into the air. Okay, so if I wanted to make a solid, and you'll notice that these things are all green, that tells me that I'm going to move to working on my solids layer rather than my curves layer, because layers are really important, and let's be organized. Later on, I'll show you a model of some work that I've done either in practice or in academia, and I'll just show you how I laid out the layers. And there's just like 100 layers is a good number. More layers is more. Okay, so we're going to make a box and find a box, or just type box. Up to you how you want to do it. And we'll do this, and then we'll drag it up. And again, let's go and have a look, and we'll see that it's gone onto the ground next to this guy. Then let's make a sphere. And the way I want to challenge you to make a sphere is that I want you to make a sphere, the center of which is the corner of the box. So make a sphere where the center, the exact center of the sphere is in one of the corners of the box you've just made. How do you think you're going to do that? I'll give you a couple of minutes to try and work it out yourself. You done it? Great.
I think I just copied all the snaps that you have on at the beginning of it.
Oh yeah, okay. Oh, that's good. Yeah. Well, so OSnap is your friend here. If you haven't got OSnap on, this is something that you want to work out how to do. Looking good. If you have got OSnap on, but it doesn't look like it's working, you want to have a look at what snaps I have set up here. End, near, point, mid, int, perp, and probably quad, and maybe vertex if you really want. Now, you'll have to get used to changing those snap settings as your project moves along. Happy? We're looking good. Oh, we're looking good. Anyone still struggling? Or are we about there? Go look at the person next to you and ask for some help if you're struggling. If you've done that, then let's make a cone which sits, and I'll just show you. Really helpful little tool is something called isolate. So if you just type isolate, it'll get rid of everything else other than the thing that you want to look at that you've just selected. This is really helpful when your model gets really big and really complicated. But the next thing we want to try and do is we want to make a cone that sits with its center at the corner of the box like that, and it goes all the way up to the top corner of that box.
Sorry, how do you get out of the isolate?
You type unisolate. That work for you? Yeah, Rhino has funny language. The other thing that works is just typing show, and that shows everything. But isolate's really helpful. The thing that I often use isolate for is like in conjunction with selections. So I'll select all the curves, or I'll select everything by a particular layer, and then I'll type isolate rather than having to like find it with a mouse. Okay, are we feeling happy about this? So we go type cone, or we find cone in the thing. We snap to this bottom corner, drag it out, and then snap to that top corner. Now you'll notice there's something a little bit different between my cone here and this cone here. What do you notice about this cone here? Sorry? Yeah, it's got like a bit like a bite taken out of it. And that bite taken out of it happens to be exactly how this box fits in. So it's like we've got two puzzle pieces that fit into one another. So again, this is a bit like the thing that we did with the isosceles triangle, where we start with a simple thing, and then we do something to it to make it less simple. And the thing that we've done is something called a Boolean operation. And Booleans, if you've used other 3D modeling software, you might well be familiar with Booleans, but they're super cool. What we want to do is you can find it in here. Do you see how I'm kind of going through things really quite step by step? But Rhino's really good in that it's given you the most popular things right at the top of that standard toolbar. So these are the things that you're going to use all the time. If we extend that out, there's a little arrow at the bottom right of your two balls sort of interlocking. What we want to use is Boolean difference. What Boolean difference does is it says, take a chunk out of one shape using another. That makes sense? Take a chunk out of one shape using another. And so we click it with nothing selected, and it says select surfaces or polysurfaces to subtract from. So what's the surface that we want to, what's the polysurface we want to subtract from if we want to take a chunk out of this? The cone. So we select the cone, and it says press enter, continue. We'll press enter to continue. Select surfaces or polysurfaces to subtract with. What surface do we want to subtract with? the box. Press enter when done. And it goes thinking, thinking, thinking. And then when you click on the cone, there's a byte taken out of it.
Yeah, mine deleted the whole box.
Right. Okay. Well, let's have a look at that again. Let's undo, Control Z. Find your command, Boolean difference. Select surfaces or polysurfaces to subtract from. It's our cone. Let's enter continue. Select surfaces or polysurfaces to subtract with. And there's a little thing in brackets saying delete input equals no, delete input equals yes. So read what you see in the command and follow the instructions. And mine says delete input no, but yours might well be delete input yes. So it's quite helpful sometimes to delete the input, because otherwise you have geometry all over the place that you don't know, is this like a void, or is this a solid or whatever?
How do you change it from yes to no?
You click and it changes. Say that again. It doesn't matter. It will. So if I click delete input yes and choose that, what will happen is my cone will be munched away, like a byte will be taken out of it, but the crocodile that bit it will then be shot and killed and taken down to the dump. So it's done its job. We don't need it anymore. Whereas if what we want to do is puzzle pieces, where you want to keep both the pieces, then you may want to keep, you want to say delete input no, because we want to keep both of them. That makes sense? Okay, lovely stuff. Boolean difference. Seems to work. No, I think, well, so yeah, I think it's time for a break. Is that all right with everyone? We're doing really well here. We're going to get on to modeling some pavilion-y things and some much more sort of fluid NURBS things, but let's take 5 minutes now. Is that all right with everyone? Great. Yes, if you run.
We see that those flights of stairs.
Okay, well, enjoy. Yeah. roughly?
So no.
What's that?
Just so no.
Mel, for the first time. Oh.
Runner.
Well, that's very impressive, Mitch. You must be feeling very sprightly this morning.
It's fine. I managed to maintain it.
It's really straightforward.
What, Rhino?
Well, so what?
Yeah, it
Oh,
is.
just went straight
It really
to-
is. It's not scary. It's not scary at all.
Maybe it's a grasshopper.
Yeah. Don't get into Grasshopper until you've mastered Rhino.
They tried to teach us grasshopper.
Yeah, well, that is what's wrong. Don't learn Grasshopper. Actually, today we've got an hour. I'm going to teach you something that looks like it was done in Grasshopper, but you just did it in Rhino. You don't need it. 90% of the time, you just don't need it.
The commands are a lot more straightforward and user-friendly than reading out.
Oh yeah, by a long way.
Reading out is just so much.
Yeah. Plus, it's just linear. You do a thing, and then you do a thing to that thing, and then you do another thing to that thing, and you end up with great geometry. That one of my favorite things to do is we'll type tube. I'm going to do a tube like this. Yeah. And then I'm going to copy that from here to here, and then rotate it round, and then like intersect these two. Yeah. And then I'm going to do a Boolean intersection. How cool is that? Yeah. And takes like no time at all. And it's like super cool geometry. This is why it's really, it's so nice to use Rhino, because now the one thing you have to realize is that that's destructive editing. So I can't get my tubes back. I've done a thing and I've lost my tubes, but I could get them back if I needed to. I could just build them again. Yeah? So this is more like working with clay. It's like, I do a thing and I see how it works and I go, oh, well, I didn't like it, so I'll undo it and I'll try again. But like, yeah, it's, yeah. No, it's not at all. Okay. It's faster than Revit. Yeah. Revit is not, it's not a modeling tool. Revit's a database. That's what it is. Yeah. Mm-hmm. Yeah. Yeah. You're just working with what you see, and you're trying to be intuitive about it. One of the things that maybe we'll get to is like speed makes so much difference to design. So if you can move around quickly, then you're doing well. We'll talk a little bit about heavy models versus light models in a little bit, but heavy models, you get this thing where it kind of goes and takes like, yeah, that's it. All right. Yeah. Where's everyone gone? We need to get going. I'm going to start and they'll just have to miss out. Sad times. All right. Let's look at the power of seaplanes. When I say seaplanes, I mean construction planes, but Rhino makes a joke. There's a really funny joke in Rhino, and you have to laugh. You have to all laugh after 3. Yeah. Up here, there's a little panel called Seaplanes, just next to standard. Seaplanes, and it changes the buttons that you see at the top. So instead of standard buttons, you now have seaplane buttons. And you probably don't have the same buttons as me, but you have a little plane, like a little flying. Do you see one of those? Oh no, you don't have it. Oh, it's so sad. They got rid of it. In Rhino 5, that these buttons here, there's a little arrow that says set seaplane world top, set seaplane world bottom, set seaplane world front, world back, world right, world left. And they were little pictures of planes with floats on the bottom, like a seaplane, like a plane that flies on the sea. And there was a picture of a seaplane and it was like oriented this way or that way or that way or that way or that way. And they got rid of it and they replaced them with these boring arrows. But because it was a really funny joke, it was a seaplane that was a construction plane, a seaplane. Yeah, I was waiting for the joke too, and Rhino got rid of the joke, and it's really sad. Anyway.
It's on 7 though, is it?
No. So Rhino 7 got rid. They got rid of it in Rhino 6. It used to be in Rhino 5. That's how I learned Rhino in Rhino 5. Okay, right. Sorry about that, everyone. There's no joke for you. Now, the thing to realize with seaplanes is you're already working in 3 seaplanes. And those seaplanes, those construction planes are your top one. When you look at your top viewport, when you draw a square, you're drawing it on the ground in the top view. If you go to the front view and draw a square, oh, where's that? Let's go to the right view. We'll draw a square. Whoa, what's going on here? I want to click on it. And then I'm going to use my yellow zoom selected. And I'll select those 3 squares I just drew and click isolate. Can you see where they went? So if you want to draw something that's on this upright plane, we could use the right viewport. If we want to draw something that's on this plane, we can use the front viewport. If you want to draw something on the ground, well, you can use the top viewport. So your viewports have seaplanes within them. Now, the perspective, do you remember we were saying, I'm going to unisolate so we get everything back. Do you remember we were saying when we are in the perspective view, everything we draw goes on the ground, but it doesn't always have to. We could maybe make it go somewhere else. So here's an option. We can set seaplanes and we can set seaplane to world front, for example. We click that button, boom. And you'll notice our grid has just changed. I'll just do that one more time. We set seaplane world top, the grid goes down like this, and it's like we're working in the top viewport. We set seaplane world front, oh, the grid suddenly twists up. And now we're working like on a whiteboard. And now, if I draw a curve, it draws it onto that plane. Is everyone with me? Now, here's something cool. By the way, it's really important once you change the seaplane to change it back, because otherwise it'll start doing things you don't want to do. So the default seaplane is world top, which is this button here. Set seaplane world top. And then your grid's back onto your ground plane, and then everything in perspective is in ground plane. But here's a cool thing, right? Let's go back to our solids square. And I'm going to use my yellow magnifying glass to set my view to the middle of it. I'll make it nice and big. So we're working in the perspective view. And what I'm going to do is I'm going to make a pyramid. So you can type pyramid, or you can find pyramid in the options. I'm going to make it here. Here's a square for the base, and then it goes up like that. Oh, and actually I should be working in the solids layer. How might you get around the mistake that I've just made? I was in the curves layer and I put down a solid, and I'm like, oh, I should have organized it a bit better. I should put it in the solids layer. How might you change the layer of that thing? If you double click a layer, it makes it current, but that is basically saying the next thing that you draw will be on that layer, but it doesn't change the layer of this. You right click on the layer, and then you can say change object layer, and it will change. You select the object you want to change layer of, you select the layer you want to put it on, and you choose change object layer. So that gets me out of my mistake that I just made where I put a solid down, but I put it on the wrong layer. Okay, now here's the thing. What I want you to make sure you've done is made your pyramid so that it isn't aligned with X, Y. It's just a random pyramid. It's on the ground plane, but it's like it's sort of aligned in a bit of a funny way. Like nothing about it is X, Y, Z, you know? And you'll see already that like my pyramid is slightly kind of like slightly off. Yeah. Now, what I want to look at this example, and I've got a square, a box, and this kind of cylinder thing, and this kind of weird thing, and they're all like growing out of one of those surfaces. Yeah. How do you think I might have done that?
Set origin, you set the seaplane to the face.
Exactly. So once you've made a thing, there's an option under Seaplanes, which looks like a little ball. It's the fourth one in, looks like a little ball. And it says, set seaplane to surface. Set seaplane to surface. Click that, and it says, select surface to orient seaplane to. So I'm going to select maybe this one. Here's my surface. It's my surface of my pyramid. And it says seaplane origin, or press enter to accept default. I'm happy to accept the default, and I'm happy to accept the default x-axis direction. And now my grid is like exactly aligned to the face of that pyramid. So your grid doesn't have to be up, down, left, right, front, back. It can be wherever you want it to be. And now, if I make a box, type box, and I put it here, it's aligned off that seaplane, and therefore aligned exactly with that surface. Happy with that? How cool are seaplanes? Pretty cool. Right, when you're done, let's set seaplane back to the world top, because that's the default, everything makes sense. Because if you forget and you leave your seaplane in a funny position, you're going to have trouble later. But they're useful for like single items that you want to like align. Now, the other way you could have done it, and I wouldn't suggest you follow along with this, but the only other way you could have done it is by making a box on the ground next to your thing, and then saying to yourself, okay, so now I have to rotate it in 3 dimensions and move it in order to align it with that surface. And it's going to take you flipping ages. So use seaplanes. Okay. I want to show you a cool thing. And then we're going to move on. So am I going roughly fast enough, slow enough for people? I'll show you. Do you want to know a cool thing? Here's a cool thing. Right. I'm going to make a box. Boom. There's a box. I'm just going to center my viewport onto it so I can see. Gumball is a super useful tool. With the gumball, you can rotate. When you're rotating, you can hold shift and then it'll snap in nice orthographic ways. You can rotate in 3 dimensions. You can move it up. You can move it down. You can move it left. You can move it right. You can also, as you move your viewport around, you see you get these little squares that come up. Those squares mean move in a plane. So if I find this one, do you see I've got a green arrow and a red arrow, and my square is green and red. And that means I can move it along the green and red direction. Ooh. I can move it along the green and red direction, and it's sliding along the floor. Similarly, I can move my viewport around, and I can move it in the left, right, and up and down direction, and it's no longer sliding along the floor. Okay. The other cool thing I can do is I can hold down my mouse button on one of the arrows and click and drag, and then I can tap the Alt key. So I'll just go through that one more time. I've clicked an arrow, I've held it down, I've moved it, and I tap once the Alt key. And you'll see this tiny little plus appear. And what that means is when I let go, I get a copy of that item again. So this is going to need a bit of practice because it's a little bit like playing a sort of awkward scale on a musical instrument. But you find the gumball, click and drag, tap Alt, and then wait for that plus to come up. If you tap Alt again, the plus will go away. So it's like you're toggling whenever you tap the Alt key, whether you want to copy it or whether you want to move it. Do you want to copy it? Do you want to move? Do you want to copy it? Do you want to move? Happy with that? And we want to make one copy of our box. Then let's do something. Let's change the box. Let's rotate it. Let's, I don't know, should we scale it down a little bit? Like use one of these squishy buttons on the gumball.
Is there a way of changing only one side of the box rather than two, like scaling it?
Yeah, we can use scale 1D. Type scale 1D. And it asks you to choose a base point. So let's choose this corner. And then the scale factor or first reference point, let's choose this as the next reference point. And then we can stretch it out. Does that make sense?
Yeah.
If you're used to SketchUp, there is a way, and I don't recommend it, but you can get away with this. If you hold down Control and Shift, you can select just a face and you can move the face like you would do in SketchUp.
Sorry, if I hold down.
So you select, you hold down Control Shift if you're on Windows. And you select one of the faces. And then you can move it and it acts as if exactly as you would have done in SketchUp. Okay. So look what happens when I did it. So I'm going to undo, undo, undo. So here's a box. I've made a box. Look how many isocurves there are. It's just one simple face, simple face, simple face. As soon as you select a face and drag it, now it's turned it into a poly surface with twice as many isocurves. So now each face has 4 faces rather than 1, which means that after a while, your model is going to get much heavier. So if you can keep things being simple, that's, so if you compare those two, one has twice as much geometry as the other. Yeah. But, you know, how did
How did you change it?
when I did that thing that was like pretending to use SketchUp.
Yeah, I missed that.
Ah, okay. You hold down Control and Shift and you select one of the faces and then you can move it. But this is where there's a Rhino way of doing it, which is scale 1D, which I showed you when Lisa asked the question, how do I make it so that rather than like going like this, I just want it to go like one way. Scale 1D is the way to do it. But if you've got SketchUp in your mind, you might think, oh, I want to drag that face. But the SketchUp way leads to not so good Rhino models. And the Rhino way leads to much better Rhino models. Okay, here's a cool thing. Type blend surf, blend SRF. Blend surf. And we're going to, it says select first edge. And we're going to select an edge of one of our boxes. Let's select this one. And you'll see when you select the edge, it'll give you 2 options. And you want the one facing, well, it doesn't really matter which one you choose. It'll make sense when you follow the command through. So I'm going to choose the one facing up opposite to the direction I want to go. choose this edge, and they're going to select the second edge, and it's going to be this one. And I've chosen the one sort of on the face of the other side. And then it does that. Whoa, curves. What the hell's happening? And then I can also fiddle with these slidey things. I can make the curve do different stuff. I mean, don't go crazy, but. And I click OK. And what I've made is a surface that blends between two other surfaces. And we'll try it on the other side as well. So blend surf. I want to blend between this face and this face. So I'm going to select that edge. I'm going to choose the one that is the edge facing towards me. And this edge is the one facing, again, towards me rather than the one going away from me. And then I can fiddle with these things. And you'll see what's going on here. The curvature is being joined between those two surfaces. So you get a nice blended surface that goes between the two. And you'll also notice that that blended surface has very light geometry. There aren't like tons and tons of isocurves in it. It's just really simple curves between the two. That I really like using that as a way to make fluid forms, because it's much more controllable than just drawing random curves all over the shop. You're going between two very straightforward surfaces. And you can imagine that if this was a building, you could have a very sort of standardized block and another very standardized block, but you're linking the two together in a fluid way, rather than having like a blob that you put floors in. That makes sense. Lots of really I mean, we could go into more detail about that, but that is a tool and a cool little trick that I tend to use quite a bit. Right, we're running low on time, so let's just give an opportunity for questions, and then we'll move on to NURBS, which are like the best things ever. Yep. Yep. So I'll show you what you've done. You type blend surf. Whoop. Blend surf. Here it is. And you're going from this edge. Imagine you're a roller skater and you're on a surface. And what you want to do is you want to launch off one surface and land on the other. Yeah. So if it was a bridge, you'd be launching off one, and then there's a nice curve, and then you land on the other one. But what you've done is you've said, hey, roller skater or skateboarder or whatever, go along here, launch yourself off and land, please, like that. And it's good. And the guy's going to be like, how exactly do you want me to do that? Yeah, exactly. So actually, probably what you've done is a bit more like this. Right. Blend. I think you've probably done something like launch yourself off that surface and land yourself on that surface. And then you get this kind of big, even better, actually, hang on. You know, it'd be cool. Let's do an architectural trick, right? Your wall becomes your floor. Whoa. And then you can really start to play with some of these things. But Olivia, you found this, but you've got some you've chosen some crazy geometry to add to. Oh, really? Okay. Oh, I know why it is as well. Okay, right. So here's something else. This guy here, I'll just delete him. I'm going to make exactly the same blend surf. But I'm going to choose the bottom edge of that one and the top edge of this one. And it goes wrong. Why does it go wrong? Because I'm saying this line here, I want to go from here up to here and from here down to here, and the lines cross over. And the way they cross over means that there's this moment right in the middle where like things are like infinitely small. So what's important is to choose the same side of the line that you're trying to blend between, the same end of the edge. That makes sense? Yeah.
How do we close it? The example you have is close up to the top.
Yeah. Okay. So the way I would do it is blend surf. Go from here to here. Oh, I've made the mistake as well. Do you see? It's all gone horribly wrong. I'm going to go from here, and I'm making sure that I've chosen the right area of things. Right. So these settings, I'm going to leave them exactly the same. So it's 1, 1, curvature, curvature, straighten 30, interior shapes. Okay. Now, if I do the same between this surface and this surface, and I keep those values exactly the same, then this edge will perfectly match up with this edge. Yeah. Okay. There's I don't know whose project it is, but there's a famous project which does like something like getting distracted now. It's something like this, where we go from here to here. Can't see it. From here to here, and from here to here. Yeah, I think it's a Heatherwick on. It's like a house on a lake. Yeah, that was like a bridge or something. Yeah, so it's quite easy to do when you get it right. From there to there. I mean,
Every
yeah, that's every, so do you see, like if you keep the settings the same, then the edges will match up. That's it. Like that's done. Job done. Yeah. I've no idea. Haven't looked. I don't care about sub D anymore because you haven't got it. All right. Okay, let's move on. I want to talk about NURBS. And I want to talk, have we got time to get to this? Yeah, let's do it. Let's do it. Right. Modeling. Rule 1, modeling starts with a person. So where's your person? Hey guy, come here. Let's move down, and we're going to give ourselves a nice big blank canvas here. Let's focus on our person. Let's not get too distracted by blend surf. We can come back to it. I'm happy to help you out as and when. Modeling with Rhino starts with curves, and I'm going to introduce you to a concept that is going to just revolutionize your life in terms of organization and fluid modeling and ease of use. And it's this idea of construction curves. I've got a layer here called construction curves, and when you start a new project, my suggestion to you is you make a layer called construction curves. To make a layer, you just right click new layer, give it a name, and you can give it some color. I've given mine a red color because I always make my construction curves red. You can make them whatever color you like. Construction curves are the start of building up a 3D model. So you start with lines or curves, then you make surfaces, but architectural surfaces are never the kind of surfaces that you make in Rhino because they are infinitely thin. They're like paper, but thinner. But real life doesn't have no thickness at all. So then you start making poly surfaces, which are collections of surfaces that have thickness and have solidity to them. But the process begins with curves. So I'm just going to introduce you to a really simple modeling technique, which like every pavilion that everyone ever makes in Rhino does this. I'm not saying this is what your architecture should be. I'm just saying this is what Rhino is really good at. So we're going to make a curve with 3 control points. And I'll demonstrate why 3 in a second. And we'll put it on the floor around our guy. We'll make another curve with 3 control points. Put it on the floor next to our guy. And maybe we'll make 1 more. Something like that. I don't know. Choose a footprint that speaks to you. Doesn't matter. It's completely like arbitrary at this point. Everyone with me so far? And are you working in the construction curves layer? If you're not, how do you change your layer of your curves? Great, okay. And do you have your guy in place so you know how big the thing is that you're building? Come on, guy, get in. Okay. Now, I'm going to choose one of the curves and pick these 2 construction points. I'm going to show you that one more time. You click on the curve and you pick this point and hold down shift and pick that point. So now I've picked 2 of the construction points of the curve and I'm going to lift them up. Whoop. Here we go. Lift them up above his head, give him a bit of headroom. And maybe, I don't know, maybe I'll pick 1 point of that one and lift that one up. And maybe the middle one of this one. I'm going with my gut, you know, I'm going with how I feel. How do you feel? I don't know. Okay. I mean, it's not perfect, but you know, it's a good start. So now I've got curves that started on the ground and then they have height now. They've got 3D. And I'm going to do 2 things. I'm going to change my layer to surfaces rather than construction curves because I'm going to make a surface out of those curves. Does anyone know how you're going to make that surface? Loft, absolutely. Loft, not attic, but loft. What a loft is make a surface which goes through those 3 curves. And it goes through in a specific order, which I'm going to tell the computer what order to do it in. So I'm going to click on this curve at this end. I'm going to hold down shift and click on that curve at that end. And then keep holding down shift and click on that curve at that end. So I've got 3 curves. And then I'm going to type loft. And it gives you a little window. It says style normal, closed loft, split at tangents, align curves, blah, 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 blah. The thing that by default, it will be normal. And that will try and make you a surface that goes through all 3 of those curves. You can change it to be straight sections. And straight sections will say, well, I don't care that there's a big kink in my surface in this center bit. I just want a surface that goes from one to the next and then from that one to the last one. But, you know, normal looks kind of nice, like a sort of weird futuristic bus stop or something. I don't know. Yeah, and there's a couple of nice views of it. So when you're happy, just click OK. And if we've selected the right layer beforehand, we should now be looking at a surface on the surfaces layer that's made up of the 3 construction curves that I made. I'll give you a second to catch up with that.
So So the construction curves are basically lines or curves that you create for yourself that you can build from later.
Absolutely.
You
Yeah.
keep them as a code.
Never delete them. Never delete your construction curves, because you never know when you want to go back and say, that's exactly where that geometry is. But whilst you're working, you can turn that layer off. It's like when you did like year 1 hand drawing, you do your perspectives and you use all the like drawing boards to like draw all these lines. And actually they're lines that are really, really useful, but they don't make up the final picture. That's exactly what we're doing here with this process of saying, I'm using curves to build my building, and the curves give me huge amounts of control. In fact, I want to do a little demonstration, which is something that a lot of people do when they're starting to use Rhino, and they get very into it. And it's this. I'm going to make a pavilion, get to my construction curves layer, put down a curve, and they want to have complete control over exactly where that curve's going. So they do this. Right, how many control points have I got there? Like, I can press F10 and it will show me, or points on. There we go, it shows me all the points. Now, the two things that are wrong with that are that now, if I wanted to like lift one of these guys up, I've got to select like 1,000 points. And I've got to be like, oh, okay, right, well, and now I've got to do that one. And then it all just starts looking really messy and really horrible. The second thing is that if I loft between these guys, see how many black lines, or not black lines, but like change a bit there. I've got all these isocurves, and that shows me that geometry is much heavier. And it's like all going sort of cutting through itself. And this is just completely unbuildable, unusable geometry. Whereas this one, I've got 9 points in total, and I can change anything about my surface with 9 clicks. Yeah. The other thing is I can offset surface. So now I can give this surface a thickness of maybe 50 millimeters. Lovely, clean geometry. If I try and offset this surface, man, what a nightmare. I mean, I've got geometry cutting through itself. I've got like this bit here. Look how many black lines I've got, like, oh. And this is going to be like 50 megabytes. And this is going to be like 1 or 2. So it makes a big difference how many construction points. I would challenge you, never draw a curve with more than 4 construction points. So draw it and then drag the construction points out to match the shape that you want, rather than feel like you need to get it right when you just click each time. Okay? Now the offset, yes, happily. When you want to give thickness to something, you select a surface. The surface is currently paper thin, infinitely thin. And I'm going to select surfaces, and I'm just typing offset surface, offset surf, offset surf. And it'll give you these little white arrows. You can change which direction it's going to offset it. And there's an option called solid yes. You want to change that to solid yes. And then it will make a solid surface that's exactly 50 millimeters thick out of the surface that you just drew. Or you'll need to change the distance. You'll need to type a distance. Make sense? Cool.
How can I, sorry, how can I edit this this curve? Like if I want to drag 1 point higher, for example. Right, okay. I'm going to show you that just before the end. At the moment, if you then look at your surface and you're like, oh, I don't really like it. I think it's too tall, right? Look how tall it is against his head. So I want to go, okay, actually this curve, this point and this point need to come down. So I'm going to select the points. I'm going to drag them down to about, let's call it here. Okay. But then you'll notice that the surface, I've just created the surface. It doesn't know that the curves that made it have changed. It's just a created surface. So I delete that surface. I select the lines again.
and I type loft. And now it's where you want it to be. Does that answer your question, Lisa?
Yeah, thank you.
Now, there is an even nicer way of doing it that I'll show you at the end, but that's a bonus. I don't want to get people confused too early. That's why construction curves are really, really useful. Because you keep the curves, you can change the curves, and you can regenerate the geometry. Okay. I won't talk about Zaha and Maxi. I will talk about extract isocurve, which is really useful. Extract isocurve is the command. There's a button for it somewhere, but I've never found it. Just type extract isocurve. Click enter, and it says select surface for isocurve extraction. Oh, I'm going to extract an isocurve from you. Click that surface, and you'll see your cursor turns to give you this lovely curve that kind of like flows around as you move it across the surface. It's got this lovely like sinuous quality. Woo. Yeah. And if you want to go the other way, you can just type T for toggle. See up here, it says toggle. There's a little underline under the T. So you can type T and it will change it for you. And then you go the other way. Woo. So I'm going to do a cool thing here. We're going to change back to our construction curves layer. I'm going to extract an isocurve that's just inside of the edge. And then the tool doesn't go away. It gives you the opportunity to extract another isocurve. So maybe let's extract one that's just inside this edge. And then enter when done. Now suddenly, I've got these two lines that are on the surface. They're exactly on the surface, but they're not any of the construction curves that we had before. Now, there's another cool way you can use this is for panelization. So if you wanted equal panels, you could do this. Type divide. And it'll say select curves to divide. Well, the curve we want to select to divide is this curve at the base of your little pavilion thing. And you might think, well, that's not a curve. I never put a curve there. But an edge of a surface is a curve. So you can choose an edge of a surface as a curve. Click enter when done. And it'll say number of segments. We'll leave it at 10, or you could type another number. And then it'll put 10 points along that curve. And now, when I hit extract isocurve and select that surface, I can snap to those points. Boom. I can do the same the other way. And now suddenly I have 10 completely equally spaced isocurves along that thing. And that could be the start of some structure, for example, or it could be the start of my panels, or it could be, you know, different material for different, for each section. Another cool thing you could do is, let's just pick, I'm just going to pick these three curves and just copy them out to here. So I get another copy. I'm going to loft them again. So nice simple loft. It's gone as the wrong layer, so I'll change the layer. Let's say you want to put a little flourish in. Here is extract isocurve. I'm going to extract two isocurves quite close together in the middle. And then I'm going to move one of them up a little bit. I'll delete the surface I've just made. Now you've got 1, 2, 3, 4, 5 curves. But most of them came from the nice simple surface, and one is just come up a little bit. Now, if I loft that, I get something completely different. However, this thing, as complex as it looks, still has not anywhere near that level of like tons and tons and tons of isocurves, really heavy geometry, because I took it from the isocurve itself. So I've got this process where I start with a really simple surface, I extract some isocurves, I do something to that isocurve, and then I re-loft with the curves that I've made. And suddenly this has this, I think, like a really nice quality. And that fold is going to then also be structurally useful as well, like folding paper. And maybe I want to take that curve and just copy it down. And then I can type pipe. And this becomes some structure. So maybe it's a pipe with a diameter of, I don't know, what is it, 50? Call it 50. And maybe that's the start of some structure there. That makes sense? Right. I want to show you a cool thing before we finish, because what I want to do is kind of say each of these sessions, we're going to start with really simple stuff. We're going to move through, and then maybe we're going to end with something that is for more experienced users. So there'll be something for everyone. And then we'll have a little bit of chance for Q&A as we go through the day as well. Is everyone happy with using lofting to make surfaces? Cool. Let's take a look at this thing that looks like a hedgehog. This crazy thing. Probably if you saw this, let's just switch to rendered view. If you saw this on like Instagram or something, you'd be like, oh, wow, that guy knows Grasshopper. Yeah. No Grasshopper going on here. None at all. Let's just go through. If you want to take notes as I go through, because I'll go, fairly fast just to get the time in, then feel free. Or if you want to go along with me, then you can as well. But the whole driver for this is a couple of commands. One's called flow along surface, and one is record history. Record history, you might remember, it's next to the gumball that's down here. It says record history. Lisa, you were asking about, could I change the construction lines and the surface automatically update to remember what I just did? Yeah? You there? Maybe not.
Yeah, I am. Wait,
okay,
what did
cool.
I ask?
No, so you were saying, like, if you decide to change your construction lines, do I have to re-loft the surface?
Oh, yeah.
I said the answer was, yeah, you just got to delete the surface and try again. Record history, however, is super cool. I'm going to just demonstrate this. I'm going to start with my construction curves. 1, 2, 3, 1, 2, 3, 1, 2, 3. I've committed a cardinal sin, which is that I haven't put a guy down. And so I have no idea how big this thing is. And suddenly, oh, wow, look how big that pavilion is. It doesn't need to be that big. Let's make it a bit smaller. Boom. All right. And yeah, maybe I'm going to center my view here. I'm going to pull these guys up. And maybe this guy up a little bit. This whole thing comes up and, oh, I don't know, maybe I'll rotate it. Maybe... I'm going with my gut. I'm going with my gut here, guys. I mean, who knows how this is going to turn out? Let's just try it. I'm going to loft this, but before I loft it, I click record history. Record history is bold, so it tells me that now I'm going to make a link. Rhino's going to make a link between the things that go in and the thing that comes out. Type loft. And I click OK. I can change that layer. Right. I mean, we're familiar with this. We've seen this all already. But here's a cool thing. Because I clicked record history, I can select this curve. I can select this point. I'm going to drag it up. And Whoa. Parametric design. Patrick Schumacher, eat your heart out. So now, and here's the cool thing, right? That I put these 3 curves down, but I had no idea how it was going to turn out. Maybe I hate it, but now I can change my mind after the fact. Yeah. So that's all record history. You'll notice record history has now gone gray again. So if I do something new, it's not going to record history. It only records history when you tell it to. Right. So here we go. We've got a surface, and now I'm going to do something cool. It's called flow along surface. The flow along surface, we start with a surface. I'm going to make a rectangular surface that kind of looks a little bit like this one, but it's just flat on the ground. And the way I'm going to do it is by drawing a rectangle and typing planar surf. Planar surf just fills a closed curve with a surface, if it can. If your curve is a bit funny and isn't like flat on a plane, it won't work. But planar surface just gives you a rectangular surface like this. Then, I'm going to do this. Divide surface edge into 10 segments. Why not? Divide this surface edge into 10 segments. Why not? 10. Who cares? 10 will do. And now I'm going to make a box. I'm going to put it on the polysurfaces layer. Polysurfaces down here. And make a box that is exactly one of those little things. If you missed what I did, I'll just start again. This box here, start at that point, go down to this point, hover your mouse over it until it turns white, and then hover your mouse over that until it turns white, and then you get these nice track lines, a bit like CAD. So now I know that this box is sitting exactly sort of a tenth and a tenth of my surface. And I'm going to give it just a little bit of thickness. Don't really care exactly how much, just a bit. Here's something cool. We can make hole. Oh, make hole command. Best thing in the world ever. I'm going to make an ellipse. That ellipse is far too big. Look at that. Complete nonsense of an ellipse. Let's make it smaller. Make it smaller. Oh, that's funny. It's gone a bit weird. Oh, come on. I want an ellipse that goes from there to there to there. There we go. Made an ellipse on the top surface of my box. So this is going to be like a thing, like a cookie cutter that cuts a hole in my box. So now I can type make hole, select planar closed curves as my curve on the top, select surfaces or polysurfaces. Here's my surface I want to make a hole in, and I drag my mouse down through the box right into the ground, and I click. Let's make a nice hole. Okay. Make a hole. Make hole is really useful for like windows and stuff, like buildings. Then I'm going to array this guy. And I'm going to say number in X direction is, well, I divided it into 10, so I need 10 of them. Number in Y direction, 10, need 10 of them. Number in Z direction, going up, only need 1. And then I'm going to drag from this corner to this corner. And it gives me a little pink outline of what I'm about to expect. And you go, yeah, okay, fine, I'm good with that. There we go. You can see where we might be going, right? So I've made a really simple version, and there's this kind of all flibbity-gibbet sort of wiggly version here. But I can type flow along surface. Select objects to flow along surface. I'm going to select the poly surfaces. And guess what? They're all on the same layer. So I can just right click poly surfaces and say, select objects. Now difficulty is I've already made this, so I can just unselect these. So you hold down Control and select to unselect them. Right, so I've selected these. Actually, no, I don't want these either. Let's make sure I haven't got anything else selected. Yeah, we're good. We're good. Select objects to flow along surface. Press enter when done. Enter. Great, we got them. Base surface. Select edge near a corner. So we're going to select an edge near a corner. It's down here. Boom. Target surface. Select an edge near a matching corner. So we're going to go down here to this corner. Does that make sense? We're choosing the same corner for both. Select down here. And then it goes, I'm thinking. And whoa, parametric architecture, eat your heart out. Oh, it's called array. You can array linear, you can array polar, you can array XYZ. There's tons of different array options. Right, now let's put these two together, flow along surface and record history, and we will be in a world of joy. Okay, so I'm going to make a poly surface that is a 4-point surface. This guy here, a surface from 3 or 4 points. I'm going to put it over my hole because this is like an opening, right? This is going to let the sun in, let the rain in, all sorts. I'm going to make basically a little shade to go over my thing. Except once I've put it down, I can type points on and it gives me the points I just made. I'm just going to yank one of them up. Yeah. So I've got 3 points connected and then one kind of floating up in the air. Then record history. Array, 10 in the X, 10 in the Y, 1 in the Z, and we go from there to there. Enter to accept. I recorded history though. So now, if I drag this, all of them follow. Whoa, how cool is that? Ah, shall I do it again? Right. I'll just, so I chose points on to show me what the control points are. Then I typed array. I want to array that object 10 times, 10 times, 1 time. Exactly to the corner. I'm happy with that. So I hit enter. Ah, but I didn't do something. Record history was on, so it doesn't remember that there's any link between those two things. Okay, so again, record history on, array, this item, from there to there, enter to accept. Right, record history is on for that to the rest of them. Now I want record history on for flow along surface. Select objects to flow along the surface. I want to select, well, how am I going to select these guys here? Bit tricky, but probably the easiest way is to select everything and then go to my side view and deselect everything underneath it. Well, it would help if I could actually deselect everything underneath it. There we go. All right, let's try that again. You know what's going to be easier? Before I start, I'm just going to isolate these things, because then I don't have anything in the background. So it's much easier to select or deselect. Here we are. Record history on, flow along surface, select objects to flow along surface. I'm going to select these guys. There they are. Press enter when done. Base surface is this guy here. Target surface is this guy here. Record history was on. So if we are lucky, oh my word, look at that. It's gone a bit crazy, hasn't it? Oh, it's because I chose a control point rather than anything else. If we are lucky, I can type points on and drag that, and everything remembers where I was. And now suddenly you've got a model here that actually could respond to the sun in terms of its orientation on site, in terms of where the sun's coming from. We can look at some of the environmental stuff here. I can open up that shade, and then everything else can open up on this one as well. And I haven't used Grasshopper, it's just record history. Powerful. And how long does that take to get from 3 construction curves to this? 20 minutes. So speed is really the name of the game. Also, you notice at no point did I measure anything. There's nothing that's like exactly 1 meter big or exactly 7 feet or whatever. I used a person to give me a scale, but I want that kind of sense of making like a maquette, like a sketch model. This isn't my final model because I can do it in 20 minutes. I can chuck it and start again on another one and have another go. But it's 3 commands, like we were saying, 3 or 4 commands. We get used to them. We start using them all the time. And then suddenly we can have a whole conversation about it. It's nearly 11 o'clock and I do want to give everyone a chance to like breathe because that was fast, right? There's a lot going on there. Too fast. Right. Thanks for saying. Say early next time. No, okay, right. So
just the last part.
Just the last part. I did go fast in the last part because I was aware of it's all recorded, so you can watch it back. Just be aware that learning this stuff is like surfing on a wave. And when you're surfing in front of the wave, everything's great. The moment you fall off your board and you're like floundering in the waves, just put your hand up and say, whoa, 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 whoa. I'm floundering in the waves. You need to help me out. So next time, just wave at me because you won't be alone. I promise.
Yeah, you're not.
Yeah.
I missed everything.
To be honest, I don't care too much that you can do it. I care that you know it's doable. Yeah, because then you can go away, you can practice this, you can watch the video back, you can pause it, you can engage that way. We didn't have time, but next time, I want to show you, like, again, I think I mentioned this before, but like, how do you get stuff out of this? These are axonometric drawings of what we've just created that you could print. So if I go to my top view, I'll show you how to do this next time, but I can just go to here, I can type print, and I can get this on A3. I can give it a scale, view and output scale, 1 to 20. Now I know this is a 1 to 20 scale drawing. I'll show you how to generate this, but if you've got a tutorial and you're like, I need something, here's my model, this takes 2 minutes. At the very worst, you can do this. So here's my thing. Just isolate that. Hello, hello.
Hello.
At the very worst, this is what you can do to get out. And getting out is really important, right? Couple of options. Here's your perspective view. I'm just going to turn off surfaces so you can see the holes in there. I'm going to go to artistic, and I could print that. Just print screen and just send it to a printer and then put it on the table in front of someone. Because now you can put it on the table in front of someone and we can scribble on it. We can have a conversation about it. Similarly, if you want a side view, then maybe we need to just hide these. Just select and type hide, and they'll go away. And then this, similarly, we go to pen or artistic or whatever. Pen here. And I can type view capture to file. And then just click browse, and then it'll output that viewport as an image file that you can then print. Or at the very worst, literally just go print screen and capture a snipping tool or capture that. I think snipping tool is the snipping tool, right? Yeah, there you go. Snipping tool. Where is snipping tool? It's disappeared. There's a way to do it. Control print screen, something like that. Get your phone, take a picture, don't care, like get something out that you can then print and you can scribble over. It makes sense? So that, like, I think I just want to leave you with that, like, even when you've been spending hours in Rhino, getting something out should be quick, that you can get something to paper. But those are three options there. You can print directly from Rhino viewports, you can screenshot, you can do whatever. That was a hefty 2 hours, wasn't it? Thanks for pointing out about speed. Let's have a look at that next time and go through things a little bit slower. But I'll also make sure the video is available for you. And I think if I'm clever, I can now stop recording. Bye-bye recording. See you later. Bye.